Good afternoon, everybody. In my chemistry world, today we are going to talk about empirical formulas. And it's just another little way to try to find the lowest whole number ratio of atoms in a compound. So you're looking at the screen here. If you find the slide, it's halfway down the slide after percent composition. And we're just talking about a way that we can find some unknown formulas and substances based on maybe some other information that we're given. But first we have to figure out how to do the empirical formula. So you can see in this first one that I have here, let's see, I need to choose a pen. You guys can see that I have water. Well, the lowest whole number ratio for H2O is 2 to 1. I cannot break that down any further, so the empirical formula and the molecular formula are the same. By simply adding one or more oxygen and making hydrogen peroxide like you see over here, you can see that that can be reduced to 1 to 1. So the empirical formula is what we would find, and then from here we would continue to determine our molecular formula. So today we're just going to focus on our empirical formula, and it's going to bring some things together that we have already learned. So we're going to convert percent to moles. If we are given percent, we're just always going to assume a 100-gram sample. And you'll see an example in that in just a minute. And then we'll determine our mole ratio, and that's going to be our grams divided by the molar mass, which we've done several times already. Then we're going to divide that mole ratio by the lowest value, and we possibly need to do some rounding, and we'll write our empirical formula. Now it seems like a lot of steps, but actually it's kind of like what we've been doing everything in this chapter, that has a pattern, and once you figure it out, you can get the end result. So if you turn in your book to page 203, I'm in the yellow box on the practice problem, and it said in a lab experiment it was observed that 0.6884 grams of lead combines with 0.2356 grams of chlorine to form a binary compound. Remember, binary means 2. Calculate the empirical formula of this compound. All right, so let's take a look at what we already have. We know that we are given that lead, symbol for lead is Pb. We have 0.6884 grams. And then we have some chlorine, and the chlorine is 0.2356 grams. Okay, so if we take a look at our first step here says to convert the percent to moles and assume a 100-gram sample. Well, we don't have percents, we already have grams. So I can go right away to step 2 where it says take the grams and divide it by its molar mass. So I know that I need to round my molar mass to the 10th place. So I'm going to do lead here. So I have 0.6884 grams divided by the molar mass of lead, which is 207.2 grams per mole. So you can see that grams are going to cancel out, and I'm left with moles, and I get 0.00332, and this is moles. Okay, I'm just going to do the same thing for chlorine. So I'm going to take the mass that's given, divided by the molar mass of chlorine, which is 35.5 grams per mole, and calculate this out, and this gives me 0.00658 moles. Okay, so scanning up above and looking at your notes again, you guys can see that I did step 2. I took my grams divided by my molar mass, and now I'm going to divide by my mole ratio, by the lowest value. So if I take a look between these two, you can see that the number of moles for lead is smaller than the number of moles for chlorine, so I'm just going to divide both of them by the smallest number of moles. So 0.00332, and that gives me the whole number 1. Divide this number by the same thing, and I divide that out, and I get the whole number 2. So there's my formula. I have 1 lead and 2 chlorine. Now, in the order that they give it to you is what the order is that you normally would write your empirical formula. Now, this one's obvious because it's a metal and a non-metal, and this is the order that we have always been writing our compounds. You'll see for some of them that it's unsure. Do you write the hydrogen first, the carbon first? but as a good rule of thumb, just write it in the order that they give it to you in the problem. Okay, well, let's move on to another one. So if we take a look at this one, it is going to be the same little process. We are looking at page 204. Let me change the book here. So page 204, we are in the yellow box again. So it says 7, the commercial name for insecticide used to protect crops such as cotton, vegetables, and fruit is made from carbamic acid. A chemist analyzing a sample of carbamic acid finds 0.8007 grams of carbon, 0.9333 grams of nitrogen, and 0.2016 grams of hydrogen, and 2.133 grams of oxygen. Determine the empirical formula for carbamic acid. All right, so there's a lot of elements here in this one. So we're going to start with each of them and convert them from grams to moles. So I have this amount of carbon. I have 0.8007 grams divided by the molar mass of carbon, which is 12.0 grams per mole. And that gives me 0.0667. And I'll do nitrogen next. And nitrogen, we have 0.9333 grams divided by nitrogen's molar mass, which is 14.0 grams per mole. And I get 0.0667 again. And then I have hydrogen, and I have 0.2016 grams divided by its molar mass, which is 1 gram per mole, and that is going to be 0.2016. And then I have some oxygen, so we'll put oxygen over here, and we have 2.133 grams, that's a point right there, of oxygen, and its molar mass is 16 grams per mole, and I get 0.133. And remember, we're going to divide by the lowest number of moles. So hopefully you recognize that would be the first ones that we already did. And I'm going to divide all of them by 0.0667. And the first two, the math will be easy there for you. 667. And divide this one also by 0.0667. All right, so when I do my math here, this becomes 1, this is 1, and divide this out, and that goes into there 3 times, so I have 3 hydrogen, and this goes into here, and you probably look it on your calculator, 1.99. Now we would say that that's definitely close enough to 2. So especially when we're looking at experimental data. So I have 1 carbon, 1 nitrogen, I have 3 hydrogen, and I have 2 oxygen. There's my empirical formula. So when they equal a nice whole number, it's a pretty easy thing to do. So let's do this next example. This will be the last one on the podcast that we're going to do. And you guys can see that we have percents here. So all we're assuming that because it's percent, that it's 48.38 grams, 8.12 grams, 43.5 grams. So we're just assuming a 100-gram sample so we can go ahead and start making our conversions. So the first one that I have here is carbon, and it is 48.38 grams divided by carbon's molar mass, which is 12 grams per mole. And divide that out, I get 4.03 moles. Then I have hydrogen, and that's 8.12 grams divided by its molar mass, which is 1 gram per mole, and that is going to be 8.12 moles. And then I have my oxygen, that is 43.5 grams divided by its molar mass, which is 16.0 grams per mole, and that's going to leave me with 2.72 moles. All right, so the smallest number, hopefully you're thinking that I'm going to divide by 2.72. So divide them all by the same the lowest number of moles. And if I divide this one out, I'm going to get 1.48. I'm going to get 2.99, and this one, of course, is going to be 1. So now when I look at this, I can't really estimate this one and say, is it really 1? Is it really 2? Because we don't really have 1/2 of a molecule. So, or an element. So what I'm going to do is I'm going to multiply this by 2. I'm going to multiply by some number that's going to give me a whole number. So if I multiply this by 2, this gives me a 3. Now, just like in math, if you do something to one side of the equation, you have to do it to both sides of the equation. And this is not any different. So this is about 3 times 2 is going to be 6. 1 times 2 is 2. So there's my formula. I have 3 carbon, I have 6 hydrogen, and I have 2 oxygen. And you notice that I am writing them in the order that they are given. So if you look above one more time, let's see, oh, not above, go back. Let's see, sorry about that. So here, round and multiply to get whole number ratio. So I had a 0.5, I had 0.48. I'm going to multiply by 2. If I have a 0.33, I'm going to multiply by 3. All the other numbers, we are just going to go ahead and round to whatever the whole number is. All right, that's it for empirical formula. You have a few to try on your own, and we will talk about molecular formula at another time. Have a wonderful night.